Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 17 of the February LeetCode challenge and we again have a medium question. And this is the second question we have on the topic of backtracking. Okay, so if you have seen yesterday's question, there we were talking about lexicographically largest. Okay, it was again a backtracking question, and today again we are having similar question. I will say today's question is slightly on the easier side compared to what we have seen yesterday. Okay, so if you have not tried yesterday's problem, please do give it a try. This will teach you a lot about the backtracking approaches, and yeah, it will basically develop with thinking of how to think of various scenarios that can come during a backtracking. Okay, now I'm sure that you would have already gone through this question, so let me not take much of your time. So what we're given is we are basically given a tiles which is basically a string of capital letters. As you can see, it's going to be all capital letters and it's obviously the length is going to be between 1 and 7. This is the biggest thing that I can say is given to you. Okay, you can try any kind of approach, and obviously like, even an m-square approach will be able to solve, will be able to handle this kind of length. Okay, as simple as that. So what you have to do is, for example, let us see the other. Okay, let me tell you this. The only thing that you will have to handle is the repeating characters. Okay, let us say if the characters are not repeating within a single math calculation, you can give your answer. But since you know the letters are repeating, what you have to do is, with the length by length, you have to go. Okay, let me tell you this very frankly. This question can be solved using simple math formulas. Okay, but obviously, like there is a topic called permutations and combinations. It's basically all about permutations. Okay, so if you know those formulas, what you can do is, it's like NPR and NCRT. So for NPR, you have to just keep changing your R, and you will be getting all your answers. Okay, as simple as that. That is all that I can say in terms of maths. But again, like since this is a like yesterday we've seen a backtracking, today again it's a backtracking, and obviously like they are trying to follow a sequence of backtracking questions. So we will again try to solve it using a backtracking approach. Also in backtracking approach, you don't have to know much. Only thing that you have to know is you should not be repeating characters. For example, just let me give you a basic example, and then we'll go for the code. Okay, I don't want to take much of your time because I know you've already seen this question, you already understood the examples. Okay, now see, for example, let us say I'm taking this particular array which is in the zeroth index, and I'm combining with this particular b. Okay, to get like this a and b. Okay, now if I take the other a, remember previously I took the index 0a, but here I'm taking the index 1 a. Okay, here I'm combining it with this b, but if you see both a and b are same here. Okay, okay, the idea here is, if these two a's, though they are in different indexes, but they will be treated as the same. Okay, as simple as that. That is the only thing that I want to tell you. This is the only HK that you have to handle here. Okay, so the best way to handle them will be to take the distinct. Okay, in my case, what I've done is I'm trying to maintain frequency map here, which will tell me how many total characters, unique characters are there, and what are their various frequencies. Okay, so if you see my approach, okay, before I'm showing you my approach, see, this code that I'm showing you currently is for you to submit. Okay, the other code that I'm showing you currently is basically the one which I have designed in such a way that you will be able to explore further. Okay, here I've added a lot of print statements where you can analyze what is happening, where you can even go through the code and try to understand where you can optimize further. Okay, in the current code, okay, the code which I have submitted, this code, it it beats around 89% of the solutions. Okay, here you don't have much exploration properties. See, if you can see, I'm not putting any print statements. I'm basically not even constructing the string. Okay, the strings that you're seeing here, I'm not even constructing them. It's totally working on the logic of how it works. Okay, the idea here is I'm just trying to simulate. Okay, I'm not even like calculating the whole string. I'm just trying to simulate. Okay, had this been the case, this would have been the string, this would have been the length, this would have been the number of different sequences on all that. Okay, I'm not even generating the string. Okay, but in the solution, I'm doing everything. Basically, I'm even generating the strings. I'm storing them in a permutation list, and then I'm finally displaying it to you. Okay, so this solution I will say is for the beginners. You can try with this, but remember this is not for submitting. This is only for your exploration. Okay, because the way things are done is not a very optimal way. Okay, as simple as that. Because if you see, we are taking a string and we are doing a combining two strings. Always remember, in Java and Python, you should not be combining strings. Okay, strings are immutable in Java and Python, so you have better ways to do that. Okay, for example, in Java you can go for string builder. In Python you can go for a list. Okay, you can just add those characters, append those characters in a list, and then join them. Okay, as simple as that. So just a heads up to you what I'm going to show you. Okay, now coming to this solution. Okay, let me quickly begin. So what we are doing is, first of all, we are creating a frequency map. It's with a default dictionary. Why I'm choosing the default dictionary? The purpose of a default dictionary is that I don't have to initialize the keys and their values. I can directly start using them. And obviously, since I have passed int as the constructor in the constructor, that means the values will be initialized with 0. Okay. Now, what I'm doing is I'm going to each of the characters, and for each of those characters, I'm incrementing the frequency. So the key is going to be the character, and the value is going to be its frequency at last. Now, for all the dictionary characters, I'm taking them and I'm putting them into a list. Okay? This is the dictionary list. So if you want to see how it looks, it is going to look like this. Always for the output, you have to come to the second solution. Okay. So for example, in example number 1, you are getting the dictionary characters as A and B. In example number 2, you are getting them as A, B, and C. Okay. Now, So the frequencies will be in frequency map, and the total, like the various diction characters will be in here. Okay. Now you will ask me why I'm storing them separately. The idea here is, see, I will be, going through them. Okay. The idea here is I will have to keep, reducing and incrementing the frequencies. So while we are in the same, while we are in the for loop, while we are in the iteration. Okay. For that reason, I'm, taking them separately and, keeping them in a separate variable. Okay. That is the basic idea. Otherwise, we don't have to do anything much. Okay. Obviously, you can also go through them using the keys. That is again fine. But again, I'm just trying to be safe here. What I'm doing is I'm using this list to go through them. Okay. Because it's going to be constant throughout the, program. So yeah, I'm creating in a separate variable. Okay. Obviously, you could have also used this directly. You could have also used this directly here. Okay, that is up to you. You can have definitely done that. Okay, now, so this will tell me what are the additional characters. Here is the answer. This will be the final answer. Basically, if you see, this is the final statement that we're returning. Okay, this is going to be the function. It's a it's a recursive function, and we are using backtracking here. Okay, you will see whenever seeing something like this. You are doing a subtraction. You are calling a function, and then you are restoring the value back. Whenever you see such a thing, you should be knowing that it's a backtracking code. Okay, this code is trying to do backtracking approach. Okay, what we are doing, we'll go to that. Before that, like before going to this function, what I will do is I will try to show you the case where this function is being called. Okay, so we are going through all the dictionary characters here. Okay, what I'm doing is, first of all, let us say I'm going to start with a character I. Okay, currently the string is not built, it's a length 0 string. We are going to choose our first character. Okay, for that, what we are doing is we are going through each of the characters I, and then let us say I will chosen the character I. I'm decrementing this frequency by 1. Okay, and then I'm calling this function. In this function, I'm passing this frequency map where the frequency of this is reduced. This is going here, and this is starting this recursion. Okay, as simple as that. So once I come back from this recursion, I am restoring its frequency, and then we are going to the next iteration. Okay, the idea here is, let us say it start with a. Okay, so when it starts with a, the frequency of the other character should be with their original frequency. Okay? It should be matching with the original frequency. Now in the next iteration, let us say we are starting with b, so the frequency of a should now be restored back. Okay, that is the basic idea. For that reason, whenever, see, before calling this function, we are reducing the frequency. After coming from this function, we are restoring the frequency. Okay, that is the basic idea, right? Now, once we call this function, what is happening? See, idea here is, after every recursion, no, after every function call, the length of the string will be increasing by 1. Okay, remember, when I say length of the string, it only means logically. Okay, we are not building any string here. It just means that we are logically building a string. Okay, if you see, for every function call, we are incrementing our answer, and then let's see what we are doing. The same thing what we have seen here, the exact same thing we are doing here. See, the only difference is here we are using the frequency map, which is here a global variable. But here, if you see, we are using the f map, which is if passed to the function. Okay, simple as that. That's the only difference. Otherwise, this code, this whole code, basically, yeah, I mean, this whole code and this whole code is exactly same. Okay? But now see, we are going through every distinct characters. If the frequency in this f map is not 0, we are decrementing frequency 1. That's the idea here is, now we are going to choose this character to be our next character. Okay, as simple as that. So we are reducing its frequency by 1. We are passing this f map, okay, the reduce f map, in this particular function call. Okay, so that we can carry out the other recursions. Okay, we can carry out the other indexes, we can carry out the other characters, and then once we are coming back, we are basically incrementing it by 1. Okay, we are restoring it by 1. Okay, so this will keep continuing. If you want to understand how it works here, here I've added multiple print statements for you to understand. See, for example, first A will be chosen. Okay, then we will start building all the words which can start from A. Okay, first A will be there, then double A's can be there, then A and B can be there. Okay, then double A. Here we have taken the double A. After that, we are adding a B here. Okay, similarly, we have taken AB. Okay, here AB, and then here we are adding a. Okay, something like that. Okay, that means, like, whatever frequencies are there, based on that we will keep adding. Okay, for all the permutations. That's why if you see the naming convention, I've called it as general permutation. It's just like generating the permutations. See, in yesterday's question we were talking about lexicographically largest, but there is no such constraint here. So the only constraint is about uniqueness. Okay, it should not be a repeating one. That is the only thing here. Okay, for that reason we are maintaining you can say distinct characters, and for that reason we are maintaining the character frequency also. Okay, and this way it will be generating. Okay, then we'll go with b. Once we go with b, we'll restore every count of a. Okay, we will be restoring all the frequencies of a, and then we'll start with b. Okay, after this b, we will be adding a here. Okay, let's see. After b, a got added. Okay, remember, since we have a single b, so b cannot be added with another b. Okay, so after b, only a can be added. Now there's only one possibility. Now after another a can be added here. Okay, so if you see b, a is coming. Okay, so there are only three cases here. So b will come. After b, ba comes. After b, b double a comes. Okay, but for a there are multiple cases. A comes after a, double a comes, or after a, b can come. Okay, So these are the two alternatives. Okay, so these are the two alternatives here. Okay, which belong to, so this is the root, and these are the various child stack cases here. Okay, as simple as that. Now each of them can be going further. See, this double A can be expanded further by adding a B. This becomes like this. Similarly, this AB can be expanded further by adding A. Okay, this becomes AB. Okay, and so on. So this will keep proceeding. If you see the example number 2, it's a very huge one. Okay, there are around 188 cases. Okay, you can maybe like try to go through all of them and understand how it works. Okay, that's why I've created separately this program where I'm even simulating how the strings are getting built. Okay, remember, you don't have to build the string in this question, but for you to understand how it works, I have developed this code additionally. In my original code, if you see, I'm not building any string. Okay, I'm just passing the frequency map here. I'm not building any string here. If you see here, I'm passing the string. Okay, and here I'm trying to build the string basically. Whichever character I've chosen I, that I'm basically adding to the original string I. Okay, and that's how it gets built. Okay, and after every function call, I'm adding this to the permutations list where I'm showing it at last. Okay, if you see the output here, this is what is being shown here. Okay, so in my original code, I have not done all that. I'm not even building the string. The idea here is whenever this function call happens, we are basically getting a new permutation. So where I'm just doing answer plus one, and I'm just reducing the frequency map whenever I get an extra character, calling this function, and obviously restoring that frequency back. Okay, that is how it works. And finally, I'm returning the answer. So yep, this was all about this code. This was the backtracking code. If you want, you can even try the basic maths code where you're generating multiple permutations for different length of the string. Okay, you can try that. It should also work. I have tried that basically. Like, see, if this is not my first submission, like around 1 or 2 years back, I've solved the same question with the permutation approach that time, and yeah, that's why I remember that. Okay, so even try even that also. I want to say is there are some inbuilt functions in Python and Java where you can get multiple permutations basically just by passing the string. Okay, you can try that, but obviously there is not a very optimal approach. But again, that can be solved because the length here is not a very huge one. Okay, it's a single digit length after all, right? So yeah, friend, that was all for this particular code. If you like my efforts, if you like the quality of this video, if you like the approach being shown here, then please do subscribe to the channel. This really gives a lot of motivation to continue further. See you tomorrow. Thanks a lot.